All right, so we're going to finish up the second half of section 6.5. And we're going to start today with solving a right triangle. Okay, when you're solving a triangle, there's 6 things that you need to know. There's 3 sides and there's 3 angles. Right, so to solve a triangle means to figure out all of those things. How long is each side? How big is each angle? But in order to do that, they got to give you some information to start with. Okay. Now, we're going to be solving right triangles. We can solve triangles that are not right triangles, but that's going to be a different week. Okay. Since every triangle we solve today is going to be a right triangle, that means we already know what about it.
We already know one is 90 degrees.
We already know one angle is always 90. Okay? So in addition to that piece of information, we need 2 other things. Does anybody know what else they could give me besides the 90? The 2 what?
2 other angles.
The 2 other angles, I would have a problem if they did that. Imagine I said to you, I have a triangle. I'll tell you all 3 angles. I'll make this one simple. They're 60, 60, and 60. You know it's an equilateral triangle because you have all the angles, but would you know the sides? No, it could be a small 60, 60, 60, or it could be a huge equilateral triangle. We don't know. So they got to give me something other than the 2 angles.
So a side.
They could give me a side and an angle. Yeah, that's one thing they could do. Okay, so besides that 90, they could give me a side and an angle. And what else? I think they could give me. Yeah? It's always going to be sides and angles. Some combination of sides and angles. So they could give me the 90-degree angle, another angle, and a side. Or the 90-degree angle and... What do you think? What else? What other combination of stuff could they give me? Can't be 2 angles. So what's the only thing that's left? 2 sides. So if they give me a 90-degree angle, they're either going to give me another angle and a side, or they're going to give me both the other sides. Okay. Either one of those cases, we can solve for everything that's in the triangle. Okay, depending on which case they give me, we might use the Pythagorean Theorem. And keep in mind the fact that all the angles in a triangle add up to 180 degrees. All right, so any questions on what we're going to do, what they're going to give you, or how we're going to try to do it so far? All right, so the way we're going to do it is we're going to use one of 3 trig functions, depending on what you want to find. Okay? So the 3 trig functions you can pick from today are sine, cosine, and tangent. Okay, we're not using secant, cosecant, and cotangent. We could, but we don't have buttons for those on the calculator. So it's easier to use trig functions we have buttons for. Okay, and the way you figure out which trig function to use is you've got to look at what piece of information they give you, look at what piece of information you want to find, and determine the names of those sides. Okay? So for example, if they gave me the opposite side, and I want to find the hypotenuse, I'm looking for a trig function that has opposite and hypotenuse. So in that case, I would use sine. Right? If they gave me the adjacent, and I want to know the opposite, I'm looking for a trig function that has those 2 in it. Opposite and adjacent. Okay, so that would be tangent. So easiest thing to do here is to draw a diagram out, and then you can see what's what. All right, so let's look at the first case. This is the case where they're going to give you an angle and a side. Right, so they said we have an angle in a right triangle that's 37 degrees, and the hypotenuse is 8. right? Since they gave me the hypotenuse, trig functions that have hypotenuse in this problem are going to be the ones I'm focusing on. All right, so let's sketch this out. There's our 90. Now I know the hypotenuse is going to go here. They didn't say where to put the 37, so you can put it anywhere you want. All right, I'm going to put it on the bottom. Okay, and what I'll do is I'll label these sides and angles that I don't know using the letters we normally use. Jamie, what are the letters we use for the sides? So like if you were doing the Pythagorean Theorem, yeah, we use the ABC. All right. So this side I'm going to call A, this side B, call that side C. Now that I put in my sides, what angle always has to go across from B? Beta. And alpha always goes across from A. So now that I've got my diagram, what I'm going to do is just organize everything I know and everything I don't know in a table. Okay, I don't know A. Put a box around it because I need to find it. I don't know B, but I do know C. Okay, do I know alpha? Yep. Alpha is across from A. That's 37. Okay, beta, I don't know. And what's across from C is always the right angle. So you're always going to know that. Okay, the right angle doesn't really help you. Okay, since every single problem has a right angle in it, we're never going to use that. Okay. The only thing we might use the right angle for is to help us add all the angles up to 180 and we know that fact. Okay. All right. So anything here we can find pretty quickly, either A, B, or beta. Yeah. Yeah, we can get beta quickly because all these angles have to add up to 180. Specifically, what do alpha and beta have to add up to? They're complementary. They add up to 90. All right. So just take 90 minus 37, and this is 53. Okay, so we got our first piece of information. All right, now we have to find A and B. Okay, you have a choice. It doesn't matter which one you do first. So I guess let's just do A first. All right. Now you have a choice of which angle you could use. I said we're not going to use the 90. You could either use the 37 or you could use the 53. Which angle do you think would be a better choice? Which one? 53? How come?
Because you will have the, maybe not 37, because you would have the one that you need opposite and the 8 would be adjacent.
Okay, I do like the idea of using the 37 better. Not necessarily for that reason though, but I do like the 37 better. Why do you think I like 37 better than 53? Well, it is smaller, but we're going to plug everything into the calculator. So we're just going to plug it in and hit enter. So it doesn't really matter how big the angle is.
Is 30 closer to, or 37 closer to 30 degrees, which is something that's
Okay, that's a good guess. 37 is closer to like 30 degrees, and 30 is a special angle we've talked about. But no, not because of that. Yeah?
It can be easier to simplify.
Again, calculator's going to do all the work for us pretty much.
Wait, what's your question again?
Why would I use 37 over 53?
Opposite of A.
It doesn't have to do with the placement. It has to do with what was given originally. What angle was I given?
37.
The 37. So what would be potentially not a good idea about using the 53?
It may not be right.
It might not be right. Okay. So if you use something you calculated and it's wrong to find something else, guess what? Now everything's wrong. So I'm never going to use things that I found to find other things. Always go back to what was given. Okay? So they gave me the 37, and they gave me the 8. I'm going to use those two pieces of information. And what did I say we're going to find, A or B? Which one are we going to do? A? Okay, let's do A. All right. So now, from the perspective of 37, is A opposite, adjacent, or hypotenuse? Opposite. Okay, so I'm looking for something that has opposite. And what about the 8? Hypotenuse. Okay, so the side I know is the hypotenuse. The side I want to know is opposite. Which trig function has opposite and hypotenuse? Sine. Okay, so we're going to use sine. So it's always the sine of my angle equals opposite over hypotenuse. Opposite is A, hypotenuse 8. Hey, any questions so far? And now my last step is to get A by itself.
A is opposite. Or is that just how we labeled it?
Opposite is always the side that's farthest
Or
away.
we're viewing it from the 37?
Yep,
All right.
we're viewing it from the 37.
Okay.
If we go from the 53, that could be wrong.
Okay.
So we're not even going to think about 53. In fact, forget about it for the rest of the problem. Well, we won't use it. All right. So my last step is I got to get rid of divide by 8. So how would I move that 8 to the other side? Multiply by 8. Okay, and we're going to type that in, but that's it. That's our answer. So side A is 8 sine 37. Okay, what should I check? Because if I type it in right now and hit enter, I'm going to get it wrong. My mode. I'm in radians. Okay, so most of the angles, and I think all the angles in this section are in degrees, okay, for solving triangles. So make sure you're in degrees when you're solving triangles. It's 8 sine 37. Okay, so we get about 4.815. 4.815. All right, so now I'm down to the last thing I need to find. Since I have 2 out of 3 sides in the triangle, what could I do now?
Pythagorean Theorem.
I could do the Pythagorean Theorem. But why do you think I'm going to say that's probably not a good idea?
Because you're going to have a really messy number.
First of all, A is rounded off. Okay, so if you use something you've rounded to find something else, it's going to be rounded even worse. Okay, what's another reason why I might not want to use A? Yeah? It might not be right. Okay, same idea. If A is wrong completely and I use it, well then B is wrong. Okay, the way I'm having you guys go through the problem, each part you're finding is totally separate of everything else. So just because you make a mistake on one part doesn't mean you're going to make a mistake on every part. Okay. So now I'm going to find B the same way I found A. I'm going to use the side I was given, the angle I was given, and that's what I want to find. Okay, so now focus on the 3 things I circled in green. Okay, Will, what's the name of the side that's on the bottom? Is it opposite, adjacent, or hypotenuse?
Adjacent.
It's adjacent. Okay, so now we're looking for a trig function that has adjacent, and the 8 is my hypotenuse. So adjacent and hypotenuse, trig function. Cosine. Yep, this time we're going to use cosine. So the cosine of 37 equals adjacent over hypotenuse. Okay, we're going to solve the same way we just solved for A. Multiply both sides by 8. And there's our answer. 8 cosine 37. If you're in degrees, it should stay in degrees. You don't have to go back and change it again. And we get 6.389. Okay, now, if you were doing this on the test and you had extra time, you could check it with the Pythagorean theorem. Okay, you could try a squared plus b squared and see if it equals c squared. So we could just check it, see if we did it right. What's c squared? 64. So let's check a squared plus b squared. Okay, it's probably going to come out to like 63.99 or something like that because we rounded. Okay, well, let's see. 6.389 squared. And if we did everything right, these should add up to c squared, which is 64. That looks pretty good. Okay. Again, not exact because of the rounding. So. Okay, any questions on that? Okay, another thing I usually check just to make sure it makes sense is the biggest angle should always be across from the biggest side, and the smallest angle should always be across from the smallest side. If that ever doesn't happen, something's wrong. Okay. All right, so we'll try one more of that type, and then we'll move on to the last type for solving triangles. Okay, so this one is number 39 in your book, on page 361. Okay, and Cameron, what do you think we should do right away with that information? What would you do? You would, yeah, draw the triangle. Okay, so we can figure out what's opposite and adjacent. After you've done a lot of these problems, you might be able to do that in your head to just visualize, what goes where. But for now, I would sketch it. I'm going to put A there, which means you have to put alpha across from it. I'm going to put B, beta, and C. And now I'm just going to make a table so when I'm writing all my final answers, they're all nice and organized in one spot. All right, so A we know. Okay, B, no, we don't have B. And we don't have C. Okay, alpha, yep, we know that one. Beta, we don't know. And then we have the right angle. All right, Pat, what could I could find any of these, but what do you think the fastest thing to find is?
Probably B, right? No, C.
B and C I can't do in my head. I'm going to need a calculator for those. Beta. Okay, beta we can get because that's what all the angles have to add up. We know what they have to add up to. So what's beta here?
50. 70.
70. All right, so 70 and 20 gives me 90, and that's what I'm looking for. Okay, but even if you made a mistake with beta, okay, the way I'm going to have you go through it, we're not going to use it. So just because you made a mistake here, it's not going to mess up anything else. But try not to make a mistake there. All right. All right, so B or C? Tyler, which one do you want to do next? B. All right, so Tyler wants to do B. I'm not going to use that 70. I just said that. I'm going to use the two things we were given.
Does it matter whether we pick to find B or C first?
No.
So it doesn't matter.
No, they're independent of each other. So we're not going to use B to find C, and we're not going to use C to find B. So they're separate. Okay, without me kind of going through every step, anybody think they can tell me which trig function I need here? I need tangent. Okay. I know the opposite. I want to know adjacent. Okay. Opposite is 12.3. Adjacent is B. So we'll use tangent. So tangent 20 equals 12.3 over B. All right, this one has two steps to solve it, but after I show you how to do it, I'll show you a shortcut. First thing I want to do is get B on the other side. So just like when we move the number, I'm going to multiply. And now I have b times the tangent of 20 equals 12.3. And now how would I put tangent of 20 on the other side? Divide, because that's multiply. So we'll type that in, and that's our answer for B. So if you look at the original problem, all that happens is B and tangent 20 switch places.
So 12.3 divided by tangent 20.
Yep. And we're going to use that shortcut in the future. Just take tangent 20 and B and switch places. Okay, and does anybody have that answer?
33.793.
33.793. Okay. Any questions on that? Yep.
I got 4.47.
All right, let's try it. So we got 12.3 divided by
Oh, never mind.
tangent 20.
Never mind.
794. So we'll round that up to 794. Okay, make sure if that digit that comes after it is a 5 or higher, you can round it up. Right, and now my last step, find C. All right, so I'm going to use the angle they gave me, the side they gave me, and I want to find C. Right, let's see. Well, Tommy Lee, what trig function would I use to find C? Well, we used, problem with cosine is adjacent is a variable, and again, hypotenuse is a variable in this diagram. So we'd have two variables. So what's the name of this side? Opposite. Okay, opposite is what's farthest away.
Wait, we're only going with 20, right?
Yeah,
Alright, so we use sine.
yeah, sine. We know the opposite. We want the hypotenuse. Look up which trig function has those two in it. Okay, sine. So sine of 20 equals 12.3 over c. Okay, and whenever the variable's on the bottom, what's the trick I can do here to quickly get c by itself?
Just 15 to see sine or
Just flip sine 20 and c, the reason why we just went through in the last problem. So 12.3 over sine 20. All right, so if you wonder why did I do that, I would multiply both sides by c, and then I would divide by sine 20, just like we did up here. All right, let's see what we get there. Hey, if you have something and you just want to type it in quickly, the last thing you typed, you can just press second and then enter, and it'll bring that up. Okay, so 35.963. Hey, that's it.
I got something completely different.
Get something.
I typed in the same exact thing.
Anybody else get something different, or did anyone get 35.963?
I got 13.47.
What'd you get?
Same.
You got the same thing?
Yeah.
Yep. Make sure you're in degrees. Okay. And then if you have extra time, you can always use Pythagorean Theorem. I'm not going to on this problem. Okay. Hey, any questions on that? All right. So the last type they can give you is when you have two sides. All right, so I have two of these problems. If we just need to do one, we can just do one. Unless you think we need to do two, we can. Okay, and this time they're giving me the hypotenuse and a leg. It doesn't matter what side this leg is, if it's A or if it's B. That doesn't make a difference. All right, so let's draw it out. So my hypotenuse is 12.7. One of the legs is 6.1. and I'm going to call that side B. So that means that's beta, that's alpha, that's A, that's C. Okay, any questions on just the setup of the diagram? Because that's one thing, if you get that wrong, then most likely you're going to get everything wrong. Okay. All right, so let's write down what we know. A is 6.1. Okay, we got to find B. And C is 12.7. All right, let's see. Alpha we don't know. And beta we don't know. And of course, the right angle, that's always across from C. Right, what's a little different about this problem compared to the information we were given with to start here and the information we were given with to start here? This one's a little different. Mm-hmm.
We're going to have to use the 90 degrees.
Well, let's see. The only thing we might use that for is if we wanted to check an answer. We could use it to check something at the very end, but we're not going to be able to use that 90. Unless you want to double check something at the end if we had time.
Would you use the Pythagorean Theorem to find
Yeah. Why do you think I'm okay with using it this time?
because you have all these times?
Right. Everything we're going to plug into the Pythagorean theorem is given. Not using anything that I found. Okay, so that's actually our first step. Okay, let's find B using Pythagorean theorem. Okay, so C squared, A squared, plus B squared. Okay, what I'm going to do is I'm not going to even simplify these until the very end. Okay, my first step, I want to get 6.1 squared on the other side. So how about, Fernando, how would I move that to the other side?
You subtract
6.1
squared.
squared. Yeah, I'm just going to move that to the other side. I'll figure out what it is later. I'm not worried about that right now. Okay, and then my last step, I want to get B by itself. Paige, how do I do that?
Square root the other side.
Take the square root. Now I want to know what this is. Okay, so we'll type that in and see what we get. Okay, the way I did it here, I didn't round anything off, so my answer is going to be as accurate as it can be. All right, so square root 12.7 squared. Okay, minus 6.1 squared. Make sure that everything there is under the root. Okay, my calculator almost put something outside it. Okay, you don't want that. Okay, so 11.139. Okay, that's B. Now, are we going to use B to figure out anything else in this problem? No. Okay, we found it. Forget about it. Unless you want to check your answer at the end, you could, but I don't think we're going to do that. All right, so we're going to use A and C. Okay, we're going to use both of those pieces of information, and let's start with alpha. Okay, anybody see which trig function I'm going to use to find alpha? Sine. I know the opposite. I know the hypotenuse. So look for a trig function that has the two things in it that you know, opposite and hypotenuse. So this time it's sine of alpha equals opposite over hypotenuse. Any question on that so far? And now what's different here is the variable is not in the fraction. The variable is inside the trig function. Okay? So anytime that you have a variable inside a function, The only way to cancel out this and get the variable by itself is with another function. Right? Like if I said to you, the 9 is inside the square root function. All right, and if you were solving, actually, you probably have a letter there. It'd be more like that. And I said, how can you get the x out of the square root function? The only way you can do it is to cancel the square root function with its opposite, the squaring function. Okay, and then you get your answer. So we got to figure out what the opposite of sine is.
Cosine.
Cosine?
See cosine option?
It is its cofunction, but it's not its inverse.
Oh, the other one. I'm the one.
That's kind of a real big hint, what I just said. Yeah, it's that sine to the negative first power. Right? So we did sine of alpha is 6.1 over 12.7.
Secant.
Oops. We're going to do the cosine one in a second. Okay, but anytime you've got a variable inside a trig function, you've got to cancel out that function with its inverse. Okay, so the clearest example I can show you of inverse functions are squaring and square rooting. Those are inverses. Okay, they're opposites. Well, these are the opposites of all the trig functions. Okay, I think Tyler had said it. They have these little negative ones above them. Okay, so sine to the negative 1, that's called inverse sine. Cosine to the negative 1 is inverse cosine and inverse tangent. Another way you might see these trig functions written, this is kind of an older way, arc sine. It means the same thing, but I don't see this except in older textbooks. Okay, I'm going to use the notation on the left. Right, so these are new trig functions. Okay, these are not secant, cosecant, and cotangent. These are totally different. The way we get at them on the calculator is you press second and then sine, cosine, or tangent. Right, so we're going to go back to our problem and see if we can cancel out what we have and get the variable by itself.
That says to cancel out cosine. Does it mean sine?
Oh yeah, because we did the other one first.
Check these.
Thank you. We're going to do cosine next. We just switched the order we did them. Right, so we're going to cancel out sine with inverse trigonometry. All right, so I have sine. I'm going to cancel it out with inverse sine. Okay, and the way we do it is we say we're going to take inverse sine of everything that's on the left, and then we're going to take the inverse sine of everything that's on the right. If I had enough room, I'd squeeze it in right next to it, but I don't. Okay, we're not multiplying each side by inverse sine. Okay, multiplying you only do with numbers and letters. Okay, same thing if I had this. You wouldn't say multiply each side by square root. You're not multiplying by the square root. You're just taking the square root. Okay, so the word is take, not multiply. Right, so we take the inverse sine of what's on the left. That cancels out. And now alpha is inverse sine 6.1 over 12.7. Right, let's see what we get. 6.1 over 12.7. Okay, so my angle should be 28.706. Now, if this was on the test and you were really running out of time, you could subtract that from 90 to get beta. The only danger with that is if you got alpha wrong, then you're going to get beta wrong automatically.
706.
706. Yep. Okay, what I'm going to do is I'm going to find beta exactly the way I just found alpha. Okay, I'm going to use the two sides that were given, and focus on everything I just circled in green. This time it's cosine. I'm using adjacent and hypotenuse, and that's why I had cosine written on the other page, and that's what we're going to do now. All right, so cosine of beta equals, adjacent is 6.1, hypotenuse 12.7. And now last step, I have to get rid of the cosine function. Matt, what function cancels out cosine?
Put -1 in.
Yeah, you remember the name of it? Want to help him out? What's the name of that? Yep. Inverse cosine. So take, not multiplying, take the inverse cosine of what's on the left. Take the inverse cosine of what's on the right. It's like squaring and square rooting. They cancel each other out. And now type that in. Inverse cosine, 6.1 over 12.7. Okay, and if we did everything right, all the angles should add up to 180. This is where Tyler had mentioned, can we use the 90? This is the only time I would use it if I wanted to double check my answer. Add everything I got and see if they add to 180 for a double check. If you don't have time to do that, don't worry about it. 61.294. Okay, any questions on that one? Okay, so anytime that they don't give you angles, that's when you use inverse trig. If you don't need to find angles, you don't need to use inverse trig. That's why I did not use it on the first two problems we did. I did not need to find angles. I think I'm going to hold off on that one. Okay, it's another problem where they're giving you two sides. It's pretty much identical to this one. All right, so this one's a little bit of a review from what we did yesterday. They're not actually asking me to find the angle. All they're asking me to do is find out 6 things about the angle. The sine, the cosine, the tangent. We're going to find the angle in a second. Okay, this is what we learned today, but I need to tie it in with what we did yesterday. All right, so it says this point is on the terminal side of the angle. Okay, so let me sketch that. Okay, 2, 3. 2, 3. So there's the point 2, 3. And there's my angle. Okay, what I'll do is, let's do it in a different color. Make that red. That works. Almost. That's good. All right, so there's my angle, and it said that the point 2, 3 is on the terminal side. And this is theta. Okay, so I want all the trig functions of that angle. Well, what shape could I almost make out of this diagram I have on the board? What shape? What shape? It's going to have a 90-degree angle in it, though. Yeah, we're going to make a right triangle. Okay. All I want to do is draw a line straight down right there. Okay. And theta is right there. That's my 90.
Can you back that out a little bit so I can
You see it? How long is the bottom side of that triangle? 2. Okay, I know it's 2. And what about the height? 3. And how would I get the hypotenuse? Pythagorean Theorem. 3 squared is 9. 2 squared is 4. What's 9 plus 4?
13.
So this side is the square root of 13. Now I can do exactly what we did yesterday. I've got all the sides. We don't know the angle, but that's okay. We don't need it right now.
What's the terminal side?
The terminal side, that's where the angle ends. So the initial side is always on the positive x-axis. The terminal side is where you would end up if you rotate counterclockwise.
Okay.
Okay? From the initial side.
Yeah.
All right, so we made our little triangle. Now we know all the sides in it. And that's it. So now just write down all the trig functions. So sine is opposite over hypotenuse. And we'll fix it. Cosine is adjacent over hypotenuse. Is everyone okay if I just fix it right away without going through that? Okay. Cosine and tangent is opposite over adjacent. For what I'm going to do in the next example, I don't really need to keep going, but just because we did it yesterday, I'll finish this up. This is square root 13 over 3. This would be square root 13 over 2. And 2 over 3. All right, so we found all 6 trig functions of our angle. Now, any one of these pieces of information is enough to find out how big is the angle. Okay, but in order to solve for that angle, what I'm going to do is focus on using inverse sine. Okay, so I'm going to use inverse sine, and I'm going to explain why in a little bit. I already know that it's an acute angle. Okay, how do I know that? The point 2,3 is in quadrant 1. Okay. All angles in quadrant 1 are between 0 and 90. Okay, so it's, I don't know, somewhere between 0 and 90. Okay. Let's use this to figure it out. Okay, again, you could use some other ones. I'm not going to. You'll see why. Sine of theta equals 3 over square root 13. Now, normally I would not want to write this as a final answer, but this is not a final answer. This is something I'm going to type into the calculator in a second. All right, so in order to get theta by itself, what do I have to do?
Inverse of
Yep, take the inverse sine on each side. That's going to cancel sine there. Okay, and we're going to round it off. Okay, so take the inverse sine of 3 over square root 13. Again, it doesn't matter if you plug it in with the root on the bottom. The calculator doesn't care. Okay, so second inverse sine, 3 over square root 13. Right, so you should get an angle of about 56 point, we'll round up, 31. That's how big theta is.
So we have to use the original number, not the real.
You could use either one.
Okay.
It's just, the first one was actually easier for me to type into a calculator.
Okay.
It's less stuff, and this is not a final
It's just the
answer.
same thing, but
It's the same thing.
yeah. Okay.
Mhm.
Which angle on the triangle is theta? Is it the one towards the origin? Or is
Yes.
it-
Theta is right there. Just, it's such a small picture, it's hard to put it right there. Okay, so any questions on how we just got theta? Okay, and that works fine as long as we are in the first quadrant. Okay, but if we're in quadrants 2, 3, or 4, we have to make a small adjustment to using inverse sine. Okay, and I'll show you why right here. I'm not going to carefully measure out a coordinate. I'm just going to draw an angle. Let's say we found theta in quadrant 2. Okay, we made our triangle, we did all that stuff. Now, what you really want is the angle from here, the positive x-axis, all the way to here. So, if you just had this angle, what would you have to do with it to find that entire arc in red? Exactly. Subtract it from 180. Okay, this angle right here is called your reference angle. And in quadrant 1, when you find that angle, you're done. There's nothing else to do. But in quadrant 2, when you find that angle, that's only this part. You're finding that right there. What they're going to be interested in the problem is the entire distance from there to there. Okay? So if you take 180 minus the part you find, that gives you the whole angle. All right? Now, what if you were in quadrant 3? What if your angle was down here? What do you think you'd do? Can you draw it? Okay, so let's say, draw my triangle, did all this out. I got my angle right there. And I want to know that distance. So this is what you're going to find. So what would you do there?
By 3.
270.
Yeah, add it to 180. All right, so this is 180, and this is your angle. So you're just going that much past 180. Okay, so if this was, say, a 40-degree angle, this would be 180 plus 40 more, and that'd give me my total. Okay, so in quadrant 3, and then in quadrant 4. All right, so we're always going to start by finding the absolute value, because we always want this reference angle to be positive. So we're going to find the absolute value. We're going to use inverse sine. Don't use inverse cosine or inverse tangent. You can, but things that you won't like will happen. Okay, and then you just have to determine which quadrant you're in. How do you know? They're going to give you a coordinate. You need to be able to look at a coordinate and figure out what quadrant it's in. Okay? Yeah?
By the absolute value of inverse sine, do you mean the absolute value of the actual inverse sine, or what the answer you get at the end?
Whatever you get at the end.
Okay.
Yep. All right, so just so we know right away, I'm going to write down, what quadrant am I in here? 4. Okay, so I'm going to be doing this. So the first thing I'm going to do is find my reference angle, okay, using inverse sine. So draw out, you know what, I can use graph paper if we want to make it nice. Okay, write 2, down 3. Write 2, down 3. Okay, make your triangle. Draw the hypotenuse to the origin. Draw the height to the positive x-axis. You always draw the height to the x-axis, whether you're in this quadrant, or that quadrant. Always draw it to the x-axis. All right, now we know the top side is 2. We go down 3. We'll take that negative into account when we write our trig function. Okay, and theta is always the angle near the origin. Okay, no matter what quadrant you're in, It's always the angle that's right near the origin. All right, so does everybody have what's on the left for now? Make what's on the right bigger. All right, so Amanda, what's the sine of theta there? What do I need before I can find the sine?
We need
The hypotenuse. Okay, we already did this in the last problem. This is the same triangle, just reflected into a different quadrant. Okay, it's the square root of 13 again. So now, what's the sine of theta?
Three over square root
Just remember, what kind of 3 is that? Because we went down. Yeah. Okay, I didn't write the negative here because I'm just writing the length. But remember the direction when you write the trig function. It's down. So you need the negative. And what's the hypotenuse? So now we'll use inverse sine and see what we get for theta. And remember, whatever I get here, if it comes out negative, I'm going to take absolute value. Okay, I'm just going to make it positive. All right, so we get second. It's inverse sine of negative 3 over square root 13. So it comes out as negative 56. But remember, we want to think of this reference angle as being positive. So it's just 56.31. Okay, now I'm in quadrant 4. That's what they want to know. Okay, so what would I do with my reference angle to find this arc in blue all the way around? Subtract from 360. Yeah. Theta is how much shy I am of going all the way around. So take 360 minus my reference angle. Okay, 303.69. Okay, so 56.31, that's the reference angle. But the answer to their question, 303.69. Any question on that? Okay, it takes a little practice to get used to, but we'll practice more tomorrow. All right, so I think that's our last example. The only other thing I want to mention, 2 tricks that are important. When you have angles that are 0, 90, 180, or 270, you don't draw a triangle. Okay, you don't need to go through all that work because you can't. Got an angle. Let's say you had a coordinate that was like 0, 3. I can't make a triangle out of that because it's on the axis. Okay, so if they asked me to find the trig functions of this, of 90 degrees, what I would do is just think of it when we did unit circle trig. Okay. Sine is just the y value. Cosine is the x. Tangent is y over x. I would just go back to thinking of it that way. Okay, that's the easiest way to do it. All right. But if it's not on an axis, that's when I draw the triangle, and then I do opposite adjacent hypotenuse. All right, and the last thing we're not going to do an example with today, I just want to show you a trick to remember where the trig functions are positive. Okay, I'm going to just try a bunch of angles in quadrant 1. Sine of 85, sine of 12, sine of 39. What do you notice about all my answers here? Are they positive or negative? Yeah, they're all coming out positive. Let's try some things with cosine. Cosine 85, cosine 72, cosine 12. What are you noticing here? They're all positive. And the same thing's going to happen with tangent. In quadrant 1, all of your trig functions are positive. Whether you take the sine, the cosine, or the tangent, any angle between 0 and 90 is always going to come out positive. Okay, if you go to quadrant 2, okay, start picking angles between 90 and 180. Let's try like sine of 125, positive. Sine of 150, positive. Okay, sine are the only ones that come out positive in quadrant 2. Any other angle, try cosine 120, it's negative. Okay, so in quadrant 2, the only trig functions that come out positive are your sines. In quadrant 3, tangent is the only one that comes out positive. So if you name any angle in your head between 180 and 270 and take the tangent of it, I guarantee you it's positive. I don't know what it is, but I know it's positive. And in quadrant 4, the only trig function that comes out positive in quadrant 4 is cosine. Right, so that's just a diagram to remember which trig functions are positive where. Yep.
And the first quadrant is on all, right?
Any angle in the first quadrant, any trig function, always positive. Yep. Right, so I don't know if you're going to see this diagram in the homework tonight, but we're going to be mentioning it quite a bit as time goes on. Okay, and that also finished up chapter 6. Okay, so out of our 3 chapters on trig, that was the first one. Okay. So homework, same page as last night. Okay, page 361. Okay, it's 25 to 32, 40 to 42, 45, 49, 53. And 57 and 61. You will need a calculator for some of the inverse sine stuff, but you do not need a graphing calculator.